Go.
Hello, and welcome to the Sacred Heart School ELP Traction Action NASA Challenge. Before we could begin the challenge, we had to make a literature review so we knew what the goal of our challenge was and how NASA scientists actually had to do this. We learned that the surface of Mars is made up of canyons, craters, mountains, and volcanoes. Olympus Mons, which is one of Mars' volcanoes, is the largest in the solar system. 95% of Mars' atmosphere is carbon dioxide. The other gases in the atmosphere include nitrogen, argon, oxygen, and carbon monoxide. The atmosphere on Mars is about 100 times thinner than Earth's, so we would be unable to breathe without a spacesuit. NASA scientists have to worry about these things when they design the Mars rover and their wheels. One of the things they have to worry about is the constant rising and falling temperatures of Mars. We, on the other hand, did not. We were more concerned with finding affordable and easy to obtain materials that we could use for our wheels. While testing our wheels, we decided that we should make a Mount Sharp and Gale crater of our own, like the things that the Curiosity rover is actually roving.
We followed the engineering process by identifying the problem, identifying the criteria and constraints, brainstorming possible solutions, selecting a design, building a model, refining that design, and testing the model. And we shared the solution, and these were our lessons learned. The constraints for our project were that the car had to fit in a 20-centimeter box, and it couldn't weigh more than 200 grams, and it had to travel from one side to the sand to the other, and bonus points if it could go up a incline.
During the brainstorm possible solutions stage, we tried many wheel designs. We tried doing sandpaper wheels with big spiky treads on them. We tried a paperclip design that would shovel the car forward. We tried getting friction and putting rubber bands on the wheels. We tried straws around the wheels. We even tried an interesting design like tank treads that go around both wheels.
We used data tables to organize our information, such as, was the run complete, how much time did it take, what damage did the wheels take, and any other observations we had.
After reviewing the data, we noticed that our cars needed some refining. So, like on this one, the straws were too long on the wheels, so our first iteration was to cut them shorter so the wheels could turn and not hit the car. On these ones, these would work good, but because the car was too small, they wouldn't fit on the car, so the first iteration was just to use two in the front and little ones in the back, but that didn't work. And so far, our best car was this one with smooth wheels that went all the way, but then we decided to get more traction for the incline, so we added V-treads on it for the first iteration. The second iteration was that we had to cut the V-tread shorter because they were too tall, and then the third iteration is to cut them off because it didn't work.
We kept track of our data through video clips. This first video clip is of one of our original ideas.
Good design.
The second video is of our first run to be completed by. This next video clip is of the same car going up a 50-degree incline.
Oh, ready. 50-degree incline.
And though we thoroughly enjoyed this challenge, this last clip will be of our frustration during it.
Why at the end of the year?
To choose
was our model to show you, it would have to be this one. This was our best car so far. It went from one side of the sand to the other. Now, to have this car be the best, it had some important qualities. Its wheels were strong enough to hold the car and sturdy enough to go across. And with the V-treads, it went on sand, but also without V-treads, it went on sand. And the axles in the car had to be attached very well, and also this car needs a little bit of refining.
Lessons learned. In order to gain traction on Mars, we needed stronger torque, more advanced wiring skills, a lower geared motor, and a better geared axle-wheel connection. Friction is the resistance of two surfaces to each other, and we learned that the sand and the wheels resisted each other to the point where our cars would not work reliably or consistently. In conclusion, although we were frustrated in a young group, we were glad to be given a challenge that actually challenges us.
The